Today's lesson is on creating and solving linear inequalities in two variables. I want to make sure that you're familiar with the phrases that indicate the different inequality symbols, because you're going to need to get familiar and use these to translate. So when we translate a word problem into a mathematical equation or inequality, we have to make sure we use the right symbols. So words like more than or larger than are usually pretty obvious to use a greater than symbol. And fewer than or less than or below are less than. And remember the trick for remembering less than is your left hand, it makes an L. All right, but greater than or equal to or less than or equal to, take a little bit of practice, you'd be surprised, because at least means greater than or equal to. At minimum, no less than means greater than or equal to. For less than or equal to, the one in green here, words like the maximum or does not exceed or no more than tells you that you're going to use less than or equal to. Sometimes you need to use a test number in the problem to kind of talk yourself through which symbol to use, but we'll practice it together. So let's start by looking at an example. This lesson is mostly about learning through, working through examples together. When you read a problem, make sure that you highlight in some way the important information. We're looking at the sum of two numbers, and we want it to be no more than 28. All right, two numbers. We don't know the numbers. We'll call them X and Y. Anytime you don't know something, you're going to use a variable. Sum means add. No more than. All right, so if it can't be more than 28, it must be less than 28. But can it be equal to 28? Well, let's think about it. No more than 28. Sure, it can't be 29, but it could be exactly 28. So we're going to use less than or equal to. Notice that for everything in the problem, I've kind of translated it into something mathematical. So now I can write the linear inequality to represent the situation. The sum of two numbers is X plus Y. And that has to be less than or equal to 28. List some possible combinations of numbers that would satisfy this inequality. I bet you could think of some off the top of your head. Staying under, right, less than or equal to 28 is pretty easy. X could be 2 and Y could be 7. Those only add up to 9. That's definitely less than 28. I'd like you to go to Desmos and put this inequality in. And let's take a look at how you could pick combinations from your graph. Pause the video and put this in Desmos now. All right, remember what we've learned about graphing inequalities. X plus Y is less than or equal to 28. The solutions to this inequality is everything in this pink shaded area, every single point. That means there are an unlimited number of options here. For instance, this point. Okay, this point is the point 10, 5. So if X is 10 and Y is 5, that's a solution. Because this is an equal sign, all points on the line are solutions as well. So this point, 10, 18, is also a solution if X is 10 and Y is 18. we are equal to 28 when we add them together. You can see how every combination of x, y that is in this shaded area will work in this inequality. Let's try another example together. In this one, Eula needs to buy binders, and they cost $4 each. Binders cost $4. All right. Notebooks cost $2 each. Seems like important information. Binders are $4, notebooks are $2. She can spend no more than $20. All right. Here is our inequality phrase, no more than $20. That means I can't go over. So it has to be less than 20. Can it be 20? Yes. No more than 20, but 20 will work. So we're going to use less than or equal to here. All right. If binders are $4 each, then we need to, what we don't know is how many binders, right? So we'll call that X. And we don't know how many notebooks. Put X is the number of binders. And we don't know how many notebooks, so let's make Y the number of notebooks. These are the things we don't know. When you're going to the store and you're buying 3 binders, let's say, and they're $4 each, think about how you know how much your total is going to be. You multiply those numbers, right? Well, we're going to do the same thing. But when we multiply a number times a letter, because we don't know how many binders, we just write them next to each other, 4x. And because we don't know how many notebooks, we're going to use y for the number. We'll multiply that y by 2. That's our 2y. When we add these together, we get the cost of the binders plus the cost of the notebooks. And we know something about our total. It must be less than or equal to $20 because that's all we have. So these mini expressions, each term gives you the total for each thing. This is the total for the binders, $4 times however many I buy. The total cost for the notebooks, $2 times however many I buy. And when we add those numbers together, our total money spent needs to be less than or equal to $20. Go ahead and put this in Desmos and write down 2 or 3 possible combinations of binders and notebooks. Keep in mind, we're looking in the shaded region, and it doesn't make sense to use fractions or decimals here. While they're in the shaded region, I want you to think about why that doesn't make sense, because we're going to talk about it in class. Okay, here's one I want you to try. Pause the video, underline all of the important parts, and look back and see how we did it on the other examples. Set up a linear inequality and then come back to the recording and we'll go ahead and go over it. Okay, how did you do? Did you label everything like I showed you? We have $8 an hour at a grocery store. What we don't know is how many hours. So X will be our number of hours at the grocery store. He earns $10 an hour teaching guitar. But again, what we don't know is how many hours he's going to teach guitar. We do know that however many hours he works at both of these jobs, we know how much money he earns. And so we multiply $8 times the number of hours at the grocery store, and we multiply $10 times the number of hours at teaching guitar, right? So this is the grocery I'll put money for grocery and money for guitar. And when I add those total money together, I know it's at least $200. Greater than or equal to works here. I want you to think it through. At least 200 means more than 200 works, but less doesn't. However, at least 200 means exactly 200 is an option. And so we put an equal to underneath that. You really have to think these through each time. In Desmos, we're going to figure out that if Marcel works 20 hours at the grocery store, that's our X, how many hours does he need to teach guitar lessons? So we're going to make 20 our X. And we'll look in Desmos by putting this inequality in there and figuring out what Y will be. Go ahead and try that now and then come back and check your work. So here's our graph of 8x plus 10y is greater than or equal to 200. Notice I labeled my axes to remind me. And you can do that in Desmos as well. It allows you, if you use the wrench, to type in X and Y axis labels. But the idea here is that if he worked 20 hours at the grocery store, how many hours of guitar would he need to teach for the inequality to work, to be in the shaded area or on the line? Well, at 20 hours, this is the least amount of guitar hours he needs. He needs to have at least, look, 4 hours of guitar. Do you see it? 20 hours at the grocery store. Could he work 5 or 6 or 7 or 8 or 9 or 10? Absolutely. But the least number of hours he'd need is 4. Okay, so at least 4, it could be more. We're going to do lots more practice of these in class. You can go through the slides yourself before class and give them a shot, but we will work on them together during class. Be sure to review the lesson summary at the end here and make sure that you're forming the habits in reading these word problems and identifying all the important information in order to write the correct inequality.